chemical that speeds up a chemical reaction, but actually doesn't participate in the reaction. So remember, in a chemical reaction, bonds are broken, rearranged, and put back together to form new things. Catalyst doesn't do that. It just hangs out and speeds it up.
So is catalyst a chemical?
It's a chemical. And once you get to chemistry, you'll figure out exactly why that is later. I don't want to go there today, but all you have to know is that that chemical will make the reaction go faster. But it doesn't get used up. Now, do you remember in the reaction lab, we had manganese dioxide and peroxide?
Yes. Right,
So
yeah,
yes,
I remember.
The chemical reaction was this. The peroxide breaks down to water, basically, right? So like if you left the peroxide out, you know, you have peroxide at home for cuts and stuff, this and stuff. But if you left that open for a long period of time, it'll eventually become water. Now, usually, when you break down the peroxide,
I want to do it.
break down the peroxide into water, that's really, 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 really slow. So, remember this black stuff, the manganese dioxide?
Yeah, I remember.
That's actually catalyst that speeds the chemical reaction up. Remember I said a catalyst is not used up, right? It doesn't participate in the chemical reaction. Remember I just said that? Right? So I'm going to prove this to you. After you did that lab, you dumped it out in the beaker. I'm going to prove to you that there's manganese dioxide still in here. So what I can do is I can take the water out, and guess what would be left over? Manganese, right? It was never used up. It wasn't part of the chemical reaction. It was just a catalyst. It just kind of hung out. This stuff is called acetone. And this reacts with the air. But this also is a really, really, really slow reaction. I'm going to walk this by you. I want you to figure out if you can tell what it is. So you may have smelled it. Smell it? Oh, nail polish remover. Very nice. What's the main component of nail polish remover is acetone. If you leave, now ladies, or I guess guys too, but ladies especially, what if you leave your nail polish remover out?
It smells really bad.
What happens to it? You know? Well, because if you leave your nail polish remover open, it's not going to work anymore. Because this reacts with the air to form something new. And that takes a really, really, really long time. So I'm going to use a catalyst to speed this up. Okay? What are pennies made of? Copper. Guess what copper says?
Catalyst.
Catalyst. It speeds up the reaction between this and the air. Okay? So, you're going to have to kind of think on this one a little bit. Okay. I'm going to get this copper penny all hot. That sounds awkward. And so hot that it glows.
Cool.
And what we're going to do is we're going to time how long it takes to cool off, just by itself, in the normal air. Okay? Oh, actually, can we even wait the lights in the back, too? Oh, did I tell you that the reaction between acetone and the air is exothermic? That means it does what? It gives off a lot of heat, or it gives off heat, right? Okay. So if I make this reaction wait. If I make this reaction speed up, it'll give off more heat.
It smells like
Ready, count. Can you see it? Go.
1, 2, 3, 4, 5,
Can't say it.
We can't see the penny.
8, 9.
So it's kind of 10 seconds to stop glowing, right?
Right.
Okay.
Wait, do it.
This is right now reacting with the air, forming other stuff. And it's exothermic, but it's not hot because this is a really, really slow reaction. But what I'm going to do is I'm going to put the penny in here, and so it should speed it up, right? And so, how long did it take for the penny to cool off?
10 seconds.
So then, what do you think is going to happen? If I speed up this exothermic reaction, what should happen to the penny?
It should stay glowing.
What?
It should stay glowing.
Why?
Because it's exothermic.
It's making this reaction give off heat, which will keep the penny hotter. Right? Yes?
Sí.
Is everybody getting that?
Sí, señor.
Oh, sorry. Can you get the lights again? Ready? Count.
1, 2, 3, 4, 5, 6, 7.
Can you please stop being annoying? 10-ish, right? All right, now I'm gonna do it again, but I'm gonna put it in the reaction. So if it speeds up this, hello, if it speeds up this exothermic reaction, this will release more heat, which will keep the penny hotter. Right?
Right.
Okay, let's try it. Let's get this all hot and bothered again. Oh, there we go. All right, ready? Go. 1.
Oh, I see it.
Farm.
Oh, I see the
It's
penny.
staying hot. Why is it staying hot? So the copper is speeding up the exothermic reaction, so it's producing more and more heat, which is keeping the penny hotter.
You can see the penny.
Right?
That is a glowing penny.
That is cool.
What if you dropped it? What would happen?
Yeah, what if you put it in the
Keep
liquid?
it in there.
Yeah, put it in the liquid.
It would go out.
Still, look how it's still glowing.
Still on fire.
I'm getting this.
You can't even see.
Look, it's still glowing. Give me a sentence that summarizes this.
Use a catalyst and the chemical reaction process.
Yep. What's happening to make the reactions go faster in each of the 3 cases, Abby?
The molecules collide faster.
The molecules are colliding more often.